I believe so. So now the only other thing is I need to open the proposal here. Here we go. Hey, Stephen, can you hear us?
I can. How's it going?
Pretty good. All right. So that works well then. We just need to extend. So I can just throw this over. I'm sharing the second screen actually. There we go. Alrighty, so this is a continuation of the thing we spent last week, like half an hour on. So I think we went over bit converter. I believe we went also over system convert.
Not really.
No?
That's where we basically didn't get past bit converter.
Okay, so then let's just continue here at system convert.
It also wasn't clear to me. So did we say that everything that's on bit converter as I currently had it outlined was like good to go, or were there changes that need to be made?
I believe we said we're somewhat fine with that. I think, let me actually pull up the notes from last time.
Where did we land with like throwing, etc.?
I feel like we decided that on bit converter, all the like, you know, to Boolean, et cetera, were just mirroring the behaviors of their existing. And so they would throw if given insufficient data, and they would ignore excess data. And then I don't know that we particularly landed on the verb for the methods that are currently named try copy bytes. I think we decided that we understood when data would be returned and that it would be an exception.
Right.
So false was just, you didn't give me enough space to write it down, and throw for anything that's invalid. Except I don't think any of these can be invalid.
Yeah,
So.
I don't think they could be.
So those are easy.
Yeah, those seem like easy.
So it sounds like the open issue is just on the copy verb. And then I had one other question, which was, there are a bunch of these APIs. Well, let me back up. We're very inconsistent today across the framework in what we call some parameters. You know, a thing that takes a byte array, sometimes it's called bytes, sometimes it's called value, sometimes it's called B, sometimes it's called, you know, whatever. Should we be consistent across all new APIs with regards to like anything that's a span of byte is called bytes, or should we map to whatever the thing that's being overloaded currently uses, like consistent with the current API or consistent across all new APIs? Do people have an opinion?
I would say, generally speaking, the consistency that is more important to me is on a given type. I mean, if you introduce a new concept across, you know, a set of types, you know, of course, it would be really good if you could have consistency across all of those types. But if you basically just add logically overloads to existing stuff, then I'd rather pick to the naming that the existing type has been using. So if one type says bytes and another type says, you know, value or array, then that's unfortunate, but then you should probably stick with that. Now, if it's literally called array and the new thing is not an array, I wouldn't call it array, I would just call it bytes at that point. But I think we need to have like consistency within, you know, the existing types. You know, locally, I think is more important than globally, if that makes sense.
Here,
It does. Okay.
probably say that instead of bytes, that it would be destination, but
Everything else right now on bit converters uses value. And all the other existing APIs.
well, that's all the like. But on the new like try copy bytes, because the bit converter stuff right now returns an array, so it doesn't talk about the output of from a Boolean.
Yeah, there's no copy, but there's get bytes. Even the get bytes returns takes a value.
Right, but it doesn't. But it returns the array, and so now this is we have the writable destination. So like I would call that destination. But.
Yeah, I would also call it destination.
think that's what we called all the other things for the new span APIs as well.
Yeah, whenever I have a parameter like that, I always get confused if it's just called bytes or something, especially if there's like multiple parameters.
We actually went back and changed everything to source destination.
Yeah.
And I think bytes consumed in bytes, depending on whatever, bytes consumed in bytes written, so it was very clear.
Yeah.
So we can do that. We can do destination for the bytes.
We're only hearing every other word you say, Stephen.
Sometimes, yeah.
Let me put on a headset.
I'm not sure it's the headset. I think it's more like the internet connection, I believe.
It could be locked up.
That is true.
I'm just looking at other copy methods to see if we have a clear, consistent pattern. Certainly when there's source and destination on the static methods, there's source and destination.
Yeah, that seems to be sensible.
Can you hear me better now?
Yes, much better actually.
Okay. Okay, so try copy bytes, bool value, span byte destination. Is that? Or at least we can go with that for now and see if looking at subsequent APIs changes our mind. What about on the 2char, 222, and 16? Should all those be source, or should they match the existing overloads that use the name value?
I think they should match the existing ones in bit converter.
I'd go with value.
Yeah.
Because these are just overloads. So
Yeah. Well, in this case, they're not really overloads because they're literally our new names. But I think generally speaking, in this case, the question is, I think Chris brought this up as well. Should we call this something else that not copy bytes, more like encode or something? Because it's really not a copying, right? It's not like you're copying, right? You're literally encoding the value, right?
No, these are literally copies.
But they're also equivalent to writing, isn't it? You're really writing to the span.
Yeah, I mean it's taking the in-memory representation of this data type and putting it into the span. So it could be write, it could be copy, it could be get. Get from one place and write it to the other.
Other overloads are called get bytes. So let's try get bytes not work.
Well, you're not getting here. You're writing into that span.
You're getting them.
You're getting the bytes.
Yeah, getting implies
Getting
return.
bytes from the piece of-
The bytes come from that number and go into your span.
Does anybody have like a massive knee-jerk reaction to write? Because I think write is more logical.
Yeah, I'm leaning towards right. I'm looking at other existing writing here right now.
I mean, copy to me is more like if you have one array and you copy from one to the other. But copying for one value seems odd.
Right. Seems fine.
So it would be try write, and I think if we go with write, I think it's fine if the thing is called value.
The trouble is, I can't find any static write methods right now that basically take the thing you're writing to as one of the parameters.
That kind of everything we've done so far has been allocated to the byte array.
Well, a lot of the write APIs are coming from the wrappers, like the text writer, text reader. You're writing to a part of stream. You're writing to the instance.
You're changing the state of something that you're not driving.
I actually haven't found a static write method yet, but I'm looking for the Marshall ones kind of have something.
If we had overloads of write directly on span and one place, we got removed. It was like a write T generic function or something. I don't know whatever happened to it. We could solve the problem except
The Marshall write APIs that are static, they take the actual sort of the thing you're writing to as NPTR as the first parameter and then values afterwards. So if we're going to be consistent, we have to reverse this through order.
So they take destination comma value. I mean, they don't name it nice. It's like a header.
That's a good point, actually.
Is there any reason why these can't or shouldn't be extension methods too on span?
That's what I said, we had a write before, a generic write T that did exactly this. But it got removed because I think it's unsafe, or the version of it that existed was unsafe.
The generic one I can imagine is unsafe, but specific overloads with these things might be okay. These feel like they are not logical.
So, I mean, there's a tension here between putting it where we think it might actually belong and discoverability. You want people who are currently using bitconverter.get bytes to be able to easily switch over to the span-based thing. Also, if you think of span byte logically as the equivalent of byte open brace, open bracket, close bracket, there's no write on array. Why would there be a write on span? I'm not arguing against that. I'm just playing devil's advocate.
There's actually no reason why we can't put the span extensions directly on byte converter so they kind of discoverable from both sides.
We could do that. Seems odd, but
You just have basically write extension for span on bit converter.
yeah. So I somewhat undecided. So I think the challenges that we have, for better or worse, in the framework, a few static methods that probably could have or should have been instance methods on the types, but we can't convert them into extension methods because they are not on a static type. So for example, like in.parse, right? Or a bad example because it's not, shouldn't be an extension method. But there's other ones, I forgot which one it is, like I forgot. I think array has a few ones that could, yeah, for example, search on array could have been an instance method. But it's not. So I think for those kind of things, I agree with Stephen, we should make up our mind what consistency do we want to have. And I think, I don't know, for real primitive types like span and array, I think people are used to the idea that they're static helpers somewhere. They're not necessarily instance methods, so I wouldn't pollute the instance of the type with them making them extension methods. Even though you could. So I think leaving them on bitconverter seems like a good idea. I mean, we already have, by the way, span extensions as well, which we do some things for, generic specialization and other reasons. But I think these should probably go here. The only counter argument to Stephen's point is that we introduce a new name, right? They're not really overloads. Like you still have to do bitconverter dot and scan for the span-based APIs.
So if we put them on bitconverter, which is static, so we could host extension methods in it. If we put them on bitconverter and we write them as if we were going to make them span extension methods, but don't put this keyword on them, we can always go back and add it later because that's not a breaking change. But I do agree that, with stream.write, the stream moves when you write to it, but with span.write, you're the same span. So writing to the same span twice is overwrite, and writing to the same stream is not. So looking instancy, I think, might be the wrong approach. So I would leave it on bitconverter. Possibly go with try write bytes, flip the thing, because apparently our only write takes destination as the first pointer, and then call it destination and value. Back to this English last month, but English is a flex.
Yep, okay, that makes sense to me.
Do we have, I haven't looked at all the span yet, but do we have a write method or do you want to expand at all? How do you basically just write to the index, you just index directly into it?
That's what I was saying.
I know you used to have the generic one, but so the only way you actually mutate a span today is basically the indexer?
Well, that's not how we do it in our own code, but yes, that's how most normal people run.
Or that, or you literally just get the pointer and party on the
That's what we do.
Yeah.
Because it's
which, I mean, it is one of the key design tenets that you can do that. So it's not
That
it's-
requires using that dangerous looking function, dangerous get reference or whatever it is. Yes.
well, which
That's why the word dangerous is there. Writing code includes the word dangerous, and it says, I know what I'm doing, and then when you get the bug, someone can say, no, you didn't.
Do we not have any methods on array that will write? Today you'd have to go get bytes from then loop over yourself and then write it out to the array. If you had an array of bytes.
I mean, you have.
sorry, you want to write an array into a span?
No, I want to get get the bytes for a double,
Yes.
and I want to write it into an array. So I have to get bytes here and then
Yes.
loop over that and write it into my array. Copy it.
No, you would do copy, array or copy.
But you'd have to do a separate step to do it.
Yes. Our existing APIs are not
We
that
have nothing
convenient.
that basically takes these and converts them directly over into
I do not believe that's, yeah, I believe that's true. I mean, the only other option that you have is I think you could do a memory stream, and then you could do a binary writer over that memory stream, and then you could call write, and then that stream would eventually do the same thing.
Or
But
unsafe
it's,
in it. and
cast it to the.
yeah.
No, I was just trying to see if we have any other.
I mean, I think the closest thing that you have is literally binary writer.
Yeah,
That is logically what it is, but we don't have that for arrays particularly. You would have to literally allocate and then wrap and then keep track of what you did. Which I don't think in practice is that bad, because there's not many cases where you want to write into a bytes array by hand.
No, I was just trying to figure out if we have any other things that we compare this to. Because there's nothing preventing us from basically having these exact same methods for taking an array and you just write into the array.
Right. Although, arguably,
I mean, once you have the span, you don't need the array one.
I agree with that. I'm just trying to wonder if we had those existing methods anymore. That's all.
by the way, isn't there an implicit conversion from array to span, Stephen?
Yeah.
Yeah. So you can.
But if you wanted to index, like write into a specific location in the array, you'd slice it and then pass the slice or as the span to the method.
Oh, that's right. Yeah.
Is it implicit conversion? Or is
Yes.
Yeah, I mean, like in general, I like the order that Stephen put in here, but we're looking for the closest that we have to consistency is Marshall with fixed destination first. And
I'm
then
looking at Marshall, and they actually have both, like the copy methods on Marshall,
Yeah.
to the source first.
I would
The
generally
write
not
methods.
use Marshall as an example
Yeah.
of consistency.
Yeah,
It's just is not.
If you look at the unsafe class, it has destination first, but those are just because that's like the order the ILL codes are.
I mean, I would generally say in the abstract, I think receiver being the first argument makes the most sense from an OOP standpoint, because as you said, like logically, even if you have static methods, you think of them as instance methods. It's just that you pass the first argument, right? And so, like logically, I think the receiver should always go first.
The receiver,
The instance of that you're working on, basically.
Yeah.
like the destination.
Well, yeah. If the method is called write, your receiver is literally the thing that you write to, right?
it's just a question of, do you think of this method as I have a Boolean and I want to write it to a span, or I have a span and I would like to populate it with a Boolean? Just a
Yes.
question of directionality.
Yes. Well, I mean, generally the reason why I like the receiver being first also is that when you write to something, usually what happens over time, you have more options.
Yeah.
So if the receiver is first, it's more logical to have the options after the value. It's very weird to have value, destination, and then options. So like it seems inverted. Right?
seems
Like that's why I don't know. I think generally speaking, it makes sense to swap.
So if we do go to that point, are we still, is this still going to be Boolean, or is it, as in, it's going to be try write?
Yeah, because if you don't give a big enough span, that's the common error. And so return fail or return false if the destination is too small.
Yeah.
So we're going to have a try write bytes and swap keyword of these.
Yes. What I have right now is you would rename try copy bytes to try write. You would name the first argument
Try write bytes, try write.
try write. You want to try write bytes?
I don't know. That's not-
I mean, because the current function is get bytes.
Yeah, get bytes.
Because specifically what we're it's sort of implying the encoding of we're taking this int and we're not writing it in sort of a min-pack thing. We're writing it in system Indianness 32-bit encoding.
Right.
So we're putting the bytes into the span. We're not putting the value into the span.
I think having more bytes is probably useful just
For this particular class.
people know.
Yeah. I mean, I'm fine with
That's what
that.
it's doing.
Right. So try write bytes it is then. Then we would rename value, or we would leave.
We put span of bytes destination as the parameter name. And then
Yeah. So we would make
value
we would make the first argument bytes, would rename it to destination, and we would keep the second one as value.
Do we strongly dislike try get bytes? Because to me, get and write are like kind of a wash, and if we use get, it would be similar to the
I would
existing get
get
bytes.
you're expecting something to be returned. And you're not really knowing that you're writing into.
Well, the only counter argument is if you start with try, you implicitly get out and then bool, right?
Just try to get that.
And so you could argue that, well, the out logically because you give it the address to write to, so maybe that's okay.
Do we have
Yeah.
any precedent for try get that doesn't have an out parameter or ref parameter?
No,
No.
I mean try get value is a canonical example on
Right,
the
so I
dictionary.
think it would confuse me anyway to not have an out.
Well, the out is the span you're providing it, right?
And I think I would prefer.
OUT.
even
Yeah, I
copy.
know. Like you mean out.
I think I would prefer copy or write over get.
Yeah. I mean, the only argument for try get bytes is that it is closer to the existing overload, right? That will be the strong argument for it.
You can start writing get, and depending on your IntelliSense provider, it'd be like, well, there's a try get, and then there's a get.
But all those other APIs return you a value. It's just being-
Yeah, it's more like what Jeremy just said, right? Like when you're in IntelliSense, you type get bytes, IntelliSense will still show the other one with try get bytes. And then you can decide what to do with that.
You're essentially going to have like 4 methods or 3 methods pop up when you do IntelliSense. It's going to be 2. Actually, there's a bunch of 2.
Yep.
It's 2 something or another. Try write bytes or try get. I don't know, get bytes. So
Yeah, I mean, it's not that bit converter is very large. It is very small, as you pointed out. And the existing ones are also not, I would say,
So
super
probably
awesome, convenient,
we
and consistent.
So it sounds like what we want to do is call it write for now, and then sort of remember that we've done this to see if later it feels like we wanted to use get even though there's no out. Because right now it's, Dan points out, he would be momentarily confused by a get that has no out, and I sort of agree with that.
Oh, it's confusing that it's a get with no out, because I think it's confusing that it's a try with no out, because the try pattern is what it's based on, not the get, I think. So I think like either way, try get or try write, if it doesn't have an out parameter, it would be confusing from that perspective.
Yeah, I agree with that. I think that's basically the new pattern that we're trying to introduce.
I don't find try write confusing. Try write just means give me a boolean and tell me whether it worked instead of throwing.
Yeah.
It's try get that I find confusing because I'm not out.
Yeah, because write normally wouldn't have a return.
Well, I would argue that so the way it works in the framework right now, it's not that it's try get, right? It's the try. We call it the try parse pattern because it's usually with parse, not even with get.
Right.
But we have used try as the general prefix for operations where you have an out that gives you the actual result, and then a bool that tells you whether it's succeeded or
I
not.
understand all that, but what we're talking about here is try write where there's no out, and what you were saying is it's not the try part that implies that it's now.
No, I'm agreeing with both of you. I think if we have a try that doesn't have an out, that doesn't have currently an equivalent in the framework, I'm saying that's the pattern we're trying to introduce here because it's all about reducing allocations and other things. So we basically try to be smarter about what we do. So that's really about we're using try in other cases where it wasn't used before.
In my head, try means returnable instead of throwing, and try get means that plus give me an out parameter.
Well, no, I think usually try is if there's an out parameter. I don't
Yeah.
think there's any try methods that don't have an out.
Yes, that's what I'm saying.
Like try parse that has an out parameter.
It seems a logical extension, like
There
try
are-
send.
There are many try
Right.
write methods. I mean, not like a huge plethora, but there are many try write methods. None of them have outs.
What are those on?
Cacheral networking, UV stream handled, metadata blob builder, try-write bytes, CSDL schema writer, try-write
Immutable
schema.
reader has try copy too. So not outbound, it's just basically the input.
Yeah. So, and then like reading the page is for the try parse pattern is if it might throw an exception in common scenarios. So this is, we have a common scenario of you gave me too little memory, we would return false instead of throwing that exception. And it doesn't even mention an out parameter.
So you probably already mentioned this. You don't want to call this try copy to.
Well, that's what it started as. We'll try copy bytes.
That's what it says right there.
Yeah. There are no dumb questions except when they're. But I think we talked about this to death now. I think we're happy with that. All right, so now we can actually go to convert.
Okay, so on this one, I think that try 2 base 64 is fine. But last time we were talking about the from base 64 and what it means for try here. And we talked about it would throw on invalid data because that's what the current thing does. But I think that this data is not legal base 64 is as common as you didn't give me enough space to write. So I don't think this one hits the simple try parse pattern. We could
meaning you think this shouldn't be try at all and it should just throw exceptions, or meaning what?
Either this needs to do the transform-based multi-state return, or we could say that on invalid data it will return false and bytes written maybe 0. But so that it would have an ambiguous false value. But I don't think it should throw for non-base 64 data but return false for not enough space to write.
But today there is no convert.try from base 64 string, right? Which suggests that we have not yet deemed the invalid data case warranting of a try.
That is true, but while that argument holds for people who are used to writing convert from bytes and having a catch, I think anybody who's new to it, or people who see, oh, good, there's a try now, I don't have to write a catch, they would probably think that it's going to handle invalid data, probably more preferential than not enough space, because you can know the space ahead of time. You can't know the data.
So you can't, I don't think we can have it mean both things, because if you just return 0 bytes written, it becomes a typical loop will probably just end up ooming because it'll try and double the amount of space required, call it again, but it wasn't failing because of lack of space, and eventually you'll throw. So I think either you throw for everything, or we come up with some enum like the transformation status, but bake it into the BCL and be 100% confident that we have it right.
Yeah, I'm just worried that while we would know right now what we're picking as the common exception scenario, that I think this one has 2 that are equally valid, and that makes the try pattern difficult.
I think maybe we should go back to what we're trying to achieve here. So this is not the base 64 API we would recommend people to use when they deal with spans, right? Because
So
we
that's
have
actually
those.
what I was going to say was we just wrote a new span version of base 64 that is way more performant than the system one, and it's only span. And it's going to get shipped, and I highly doubt that system.converter is going to take a dependency on it because it's weird.
Why wouldn't we just put that implementation into convert? If it's that much better, why wouldn't we just use that in the base implementation?
So, well, and that's why I was bringing it up is one of the decisions we made was initially it was bool, and there's just too many error cases that didn't make sense. So now it returns an enum that tells you your destination's full, the source was too short, or there was an error somewhere in your stream.
Right.
Or it succeeded. So I mean, it was a 4-way enum, and it made more sense if you care about performance at all.
So that's fine. My point is just there's nothing that prevents us from converting an enum into an exception. right? So there shouldn't be a performance argument here. If we were able to make an external thing fast, we should be able to make this fast.
Yes, I think the question is just that what is it that we're trying to achieve, right? So there's you could argue in multiple ways, right? You could say the performant API for span is on a different type. This API is for convenience and consistency of what we already have, which is optimized for usability, not for performance to begin with. That's you could argue that's the current proposal, like slightly, right? Then the other one would be you'd say, oh, okay, if we already have a type that does conversion, why would we introduce a new type that's just more performant? Why can't we just merge the base64 design that we have in corefx lab and just put the methods that we have there directly on convert, and then just have one place where people can go to convert stuff? And then in span's case, the API is slightly less usable because it's involved in terms of enum, and you have to like think about that. And then the third case is just we have two different APIs and one just happens to reuse the implementation, but that's just something that we care about, but not really important.
So I think it makes sense to have a separate type with a separate implementation when the APIs are so drastically different in purpose that it doesn't make sense to merge them. In this case, it's not clear to me, like, what are the differences with this new API that's being done outside of convert beyond the return type? Is it literally just like instead of bool, it returns an enum, and instead of string, it takes a read-only span char?
So you broke up in between. Can you say that again?
I think he just wants to take his API, put it here. Why can't we do that?
Yeah,
So basically merging the members
Yeah.
with the type. Yes, I mean that's what I'm saying. To me, this is one option that we could take. I think the concern, and I have to echo Christoph here because I think that's more his opinion than mine, is that it depends on how strong do you want to be about patterns and consistency, right? So if you're into high performance code, you could argue it's easier if you have an island over here where you have a bunch of types that all do the same thing. Base64 is one of them, but there's like 6, 7 other things that are already there, and they form their own little universe. And then you live with the fact that all the APIs in that namespace are not super convenient to use, but the interactions you have with those APIs are somewhat consistent, as in they return either the same enum or at least similar enums in the interaction. How you think about that. Now, when you merge them, the risk, I guess, is that you could argue that you create the worst of both worlds, where if you're an existing customer, now you're confronted with a bunch of APIs and new types that you may not care about, and then for the new customer, well, they are now having to be very careful which APIs they call, because some of them have shitty perf, others have good perf. And maybe the API shape itself isn't good enough to tell you that.
I just think, like, if we were to add this one with a Boolean,
yes,
it throws out invalid data, we would immediately put in the documentation, this returns false only if the destination is too short. If you would like to avoid the overhead of an exception on invalid data of any form, then please call this other function instead, which says we should have just used that function in convert. Like, we're going to tell people, essentially, never call this function. It's just a forwarder to go find another one.
Yeah, so that's the inconsistency that I meant. So let's say we take the APIs that they have there and transplant them here. What you then have is you basically have different behaviors for different cases. So, for example, the existing APIs will throw when the format is valid,
because there's no existing try. Like, we could have added the try from base64 string that didn't take a span. We could have done the array one, like several releases ago, and the obvious error would have been, well, this doesn't convert as base64, and we would have had that, and then now we would be doing like, oh crap, what do we do with try, and we may run into this in other places, which is sort of why I want to bring it up now, which is the first one.
Sorry, why was the obvious error that the data was invalid rather than the array not being big enough?
No, if it was still omitting the array.
Oh, okay.
If it was try from base64 string out array, then the reason it would return false is, oh, this is invalid base64, whether that be I didn't end up with mod 3 on the input, or I ended up with too many equalses, or what, like you have, oh, this is bad data. So we could have added a try for that, and now we're adding a try that takes a span, and we've now added one more common error case, which is you didn't give me enough space to write to.
So what does the new corefx lab API, what is that? What is the signature of that one?
It's effectively like 2 and 4 without the options, and it returns enum instead.
So it returns an unum. Presumably, it takes a read-only span char instead of a string, and it doesn't take the base 64 formatting options.
It's not a span of char though. Even the source and destination are both span byte.
See, I don't think we should do that here.
Well, there's a reason why we did it, because we're trying to.
I understand you're trying to stick to UTF-8 and eliminate unnecessary encoding conversions. To me, that's the boundary between what the BCL is, at least what we where we're currently headed, and where the separate libraries currently being built in corefx are headed. Is like for convert, I think people come here when they have, when they're working with strings, and whereas the corefx lab, when it's very much focused on getting bytes off the wire with as minimal processing as possible, doing the least amount of work and getting it back out on the wire.
From the span of char one, I think it's easy to add the overload of span of byte. If we say, well, base 64, you're clearly in an ASCII or UTF-8 encoding. If you're not, then use the char one.
Well, but then you could argue that if it's about convenience, then I think for span, we're slightly inconvenienced in the sense that it's very hard to have a convenient API on convert. Because the ones that we just have on screen are also not super convenient, right? And I would argue if you're willing to call those, well, the one that in corefx lab are not that much worse to call. And they even be better because they tell you clear of what error cases you can expect.
Well, the ones in corefx lab, like if I have a string, don't I have to do like string.as read-only span.as byte or something like that to get the input to that function?
So if I remember correctly, they actually work directly on UTF-8 and only UTF-8. I don't think we have overloads for UTF-16.
No, but right. So how do I? So there's no way. How do I use the method if I have a string? I want to get the base 60.
You'd have to convert UTF-16 to UTF-8.
Right. So it is challenging to use if I have a string. It's not an easy thing to do.
Correct. I'm double checking that.
I see. So basically what you're arguing is that regardless of the fact that this thing select takes 12 arguments, you don't have to convert at least between UTF-16 and UTF-8.
Yeah.
That's
if
fair.
we wanted to add a byte one now or later, we could. But definitely what people have right now, so the existing thing is you have a string and we change that, or you have the char array,
Right.
and we change that one. So you have a char span, and then saying, fine, if you have bytes, there's no reason to call the encoding classes to turn your bytes into a char array so that you can pass it in bits if you already knew that you had ASCII bytes in the page.
All right.
But that's a second. So I like the enum. I know that Christoph doesn't like enums, but I think this would be fine of having an enum nested within the convert class that indicates it can be coarse of invalid data, or it can be detailed of data too short, improper final block padding, like, or whatever. But I think that we have two obvious error states that we probably don't want to throw in medium and higher performance code, which is this data doesn't make sense as base 64, and you didn't give me enough place to write stuff down.
So should we be looking at taking that enum from corefx lab and putting it into system with a name that's appropriate and make sure it has all the relevant members and actually ship it in the next thing?
I think so.
That will influence some of the subsequent APIs here. So it's one of these cross-cutting things we should decide on. We could also punt on it for the moment and keep going and come back to this issue.
Yes, it's also possible that if we change the verb from to something else to make it seem more obvious that the try is applying only to the part of writing it down, and that we're assuming that it's legitimate data already. But I don't know that I can come up with such a verb.
Try write from base 64 string.
Try write from legal base 64 string. Throw, it wasn't legal.
But if you do that, you basically have to have some way of people to validate that before they go to CTL.
Well, it's the if something in the API implied that it only worked on legal data, then it's allowed to throw in legal data.
That's right, but you also need to provide a way for people to check whether or not it's legal.
That's what they have right now. How do I know if this is base 64? Well, call convert that from base 64 string and just throw.
Whenever you have sort of argument errors, you need to have people need to have a mechanism to validate them.
Did you ever talk about providing overloads for encode on the corefx version of base 64 that takes strings?
So now I remember why it doesn't matter. So everything in the base 64 side is in pure ASCII anyway. So if you want to convert to an actual string, it's very easy to widen. Basically every UTF-8 character becomes a UTF-16 because it's ASCII only. On the other end, it literally is. So if you want to take a string and convert it to base 64, it's just that string dot as span dot as bytes, and you're done. And because it just treats it as a byte.
Well, but that can't be right, right?
It's absolutely correct.
Because then you'd have a null every other character.
16,
What?
You'd have a null every other.
It doesn't matter.
No,
When it's
because
coming back, it'll come back and you can just cast it to a string and it works fine.
no, but like if I have UTF-16, right,
Oh, you mean
and I have the letter A, I have prefixes with 0, right?
Yep.
So that means if I interpret this as an array of bytes, I have the value 0 followed for the ASCII value for A.
So you miss, I think, so there's two directions, right? I have data and I want to go to base 64. And then I have base 64 and I want to go to data, right? So if this is a string, it's string.as_span.as byte, like this, and
Because you want
that's
the
your
raw
source,
bytes.
and we spit out a byte array.
well, because
But it's UTF-8, this ends up
No,
being
sorry,
UTF-8
like, yeah,
string.
because if I want a base 64 code an arbitrary string, yes, that sounds fair. But I'm saying
base 64 doesn't apply on, or converting to base 64 doesn't apply to strings, it applies to bytes.
yes.
So if you wanted to do string as bytes, then that's using the system encoding, and that's fine.
So this is the
that
other
scenario
one
we
that's
don't care about.
interesting, right? So
Yes.
what happens is you have a base 64 string, and assuming that it's valid, it spits out a span of UTF-8 string, right?
No, it spins out a span of
In
bytes.
our case, I'm talking about, it's ASCII. Or sorry,
You
no,
don't
sorry,
know what
this
the
is,
output of, that's arbitrary binary data.
yes. And this one here, because it's already in whatever was this, you'll literally get back this span from this conversion.
That's if you're doing text to base 64 to text.
Which is what we're talking about, right?
No, we're talking about base 64, which is a string, to arbitrary binary data.
Correct. You get arbitrary binary data or arbitrary binary data back. So what does it matter?
No, okay, let's talk about concrete. Let me actually bring up
It's what is the input when you do base 64 to data? That needs
So
to be
this,
character based.
but it doesn't matter. So
So we're talking about this method here, right? We're
it's
talking
always
about
ASCII is what I'm
base
saying.
64 decode, right? So your source is a read-only span of bytes.
Correct.
So, but if I start with a .NET string, my data is I can convert this to a read-only span
Yes.
of byte.
So what I
But
was
now I
saying
have
was,
the read-only, like now I have literally the raw bytes of my UTF-16 encoded string. So I have a bunch of zeros in between my
yes,
letters.
and that's what I was saying is when you come out of this way, you'd have to widen it to get it back to a .NET string.
Right.
And when you do this one, you would just narrow it. Because every character is guaranteed to be in the ASCII range.
If it's valid.
Right. We're talking about valid.
Well,
Like
no,
I
we're
said,
talking about
if-
API design.
if we're
Invalid data is one
valid,
of the things that someone can pass.
as long as if you narrow down effectively that conversion, you can take a .NET string and assuming that it's all in the ASCII range, you could narrow it down. The conversion span.
Let's be confusing.
In my mind, there are two reasons why this should not be on convert. One is this exact discussion that we're having right now, because having a read-only span byte leaves it open to a lot of interpretation and it's immediately out of the realm of easy. What exactly are the valid byte patterns that are allowed to be passed in? Whereas if it's a string or if it's a read-only span of char, it's very obvious what's coming in. The second issue is, even though you don't have to change encoding with this, it's still string dot as read-only span dot as bytes, which still leaves the caller of this to effectively have to double the length of their call and figure out what the conversion is to get from string to the thing that this thing takes. And that might be totally fine for the super advanced, highly efficient API. But if our goal is just to allow people to use the existing convert dot from and to base 64 string encoding APIs, but to do it without allocating the additional byte arrays, I think that's too much of a leap. At least personally, I think that's too much of a leap.
The part where you take a string, you turn it into bytes, which will be UCS2 bytes, and we need to just be like, I know that this is all legal and I can drop every other byte. That's
what I'm
way
saying
more
is the check to do this is 2 vector calls.
that no one's going to know to do.
But what I'm saying is we could add those overloads to do vector checks.
Yeah, my original question was, why didn't we add the overload that takes string? And you said it doesn't matter. I'm saying, well,
for our scenarios.
Yes. Yeah, I think from a developer standpoint, like, you would have to know which code to write, and it's not immediately obvious what you have to do to.
So I agree with Steve. The byte-based input doesn't belong.
Yeah. So I guess my question is, if you look at on the left-hand side here, you could imagine, if we would add the overloads where we don't just take this one, but we would also take string source. Would this be an API that we would be happy with being on Convert?
I mean, that's effectively what is in the issue. If there's just an emu instead of a bool, if you put a string instead of that read-only span byte, that's what's there.
The while convert has the option of ignore white space.
These APIs also aren't in the try pattern.
No, because they follow different things, right? I'm just saying, of course, they would have to have base 64 in their name to be members on Convert itself, but
if we switch to the email model, is it still fine?
So I think that you're looking at an old API, or is this new-ish? Because I swear we changed the names to be try encode and try decode.
Did we? This is literally what I indexed like this morning.
Really?
So let me throw out one other option, which is we don't add any of the APIs to convert. If you're using the convert dot from to methods, you allocate and you go to this other library for the more sophisticated thing.
Fair enough. It means I can't use it in crypto.
Right. That sucks.
You see,
I guess I could always take a copy of the one from system.binary and just call it from a private.
So we could get rid of the word try. I think the argument was that try implied returning Boolean.
Yeah, I think we went away from try when we went to the email, I think. Because I think that made no longer any sense. But I think the question is, for me, is like, I'm not opposed to having base 64 APIs with span on convert. I guess what I'm trying to get at is that if the API shapes are somewhat close-ish in nature, but they now use different enums or different, fairly involved calling conventions, then it seems weird to have them in 2 forms. So we should either not have one side or at least align them closer enough so that they,
All right. So what about this? What if? So we have that the signature public static transform enum, whatever it's called, from base 64 string s span bytes out int, right? What if on convert you have, and you were just talking email about having 2 overloads, one that takes a string s and one that takes a read-only span byte. What if effectively you just split those 2 overloads between convert and the base 64 class? Convert gets the string s1 or a read-only span char1, and base 64 gets the read-only span byte 1.
Like right now we have convert that takes both the string and the array, and I think even with the array it takes the index and offset. So if you had a substring, we would now be forcing you to call the substring in order to call the span right.
Well, that's why I was saying, instead of taking a string s, you could take a read-only span char s.
Oh, so just drop the string altogether?
Well, because string is implicitly convertible to read-only span char, I believe. Or no, there's an add a read-only span you have to call. So maybe you have two overloads here, one for string s and one for read-only span char.
Yeah.
And then you have read-only span byte on the base 64 one.
Yes, I agree with that.
That seems fine. Can you type up how they would look like? Because honestly, I'm losing like slightly track, so I can just copy this to it.
How do I do that in Google Hangouts?
Send it in IM because I think there's an actual IM window here.
All right, hold on a second.
Do you Google Hangout IM or?
Yeah, there's a chat. You can just paste it into.
There's a chat. Chat.
Laugh was to send it over communicator that we don't have any public.
Public static. Talk amongst yourselves.
Dan is here.
He is.
But he's talking to Windows right now.
Sorry, wasn't
Oh, it's already 11. Oh, good. We're making fast progress here.
Yeah, in 1 hour we've made it as far as we made it in half an hour last time.
Oh God.
When they go up in OIN,
Okay.
Perfect.
But I'm not done yet. That was just the first one.
Both of them? Yeah.
There's three. The first two would be on convert. The third one would be on base 64.
Let's see. So it'll be like this.
From base 64, don't we need do we care about the option of whether or not we have dual white space? Like the base 64 formatting options?
Yeah, we probably add those in as the, well, I mean, I don't know. I have zero knowledge of how often that's used or not. Presumably because the existing overloads have them, we want to add them here, and we could add it as an optional parameter.
I don't know which way the default is, but like from cryptography, PIM encoded things are by convention wrapped in 62 characters. So then you would want to tell it ignore white space, bypass the new lines.
Yeah.
Right.
So we could do what I think I had in the proposal, which was have the options be an optional parameter on both of those.
Yeah.
That would be like this, and that would be base 64. Formatting option, whatever it's called.
Yeah, base 64 formatting options. Yeah, base 46, 64, whatever.
Whatever it is. Right. Yeah, this is one monster of an API.
I assume we would put it before the outs.
Oh, you don't want to do that because then you can omit it. No, you have to name them all.
Which is actually something that comes up in some of other APIs in this, is I put optional parameters after the outs because, well, to make them optional.
Yeah, to satisfy the goal of the mission. So that means you would have to push the transformation enum down. I think right now it lives in buffers, but it's in enum. It has like 4 pages.
Yeah, I mean, we would be blessing whatever this enum we come up with, which could just be the exact thing that's in corefx lab, although ideally with a different name. We'd be blessing it as the transformation result status thingy.
Yeah, the only downside is we don't have to put it in system.
Or we make it system.convert something and we only find it on these APIs for now.
Yeah, but if we plan on blessing it across other APIs.
Yeah. I don't want to say convert dot everywhere.
But if we end up with nothing else in the DCL that seems to use it, then we could vary it as a response code from system.convert.
Okay. Now, we have 2 error cases. Enough space. use tree same. All right.
What are you typing about?
Yes. I mean, there's nothing I want to hide. It's just that if you want to look at APIs and I want to type, then that doesn't work so well.
You just want us to counter check the name.
Well, that's why I submitted PR afterwards anyway, so we can all double check the note. But that's what I've written down so far. So what about the other side? That would probably just fall out, right? The other side is also easier because there's no invalid data, so it would just be insufficient space.
So 2 base 64 is only has a union given it up.
Yeah, the only error should be the destination isn't long enough.
Right.
And then I don't know if we would care about having 2 base 64 string, other than somebody going from string may not think about the fact that they can get the char span and then call new string of char span. So we might just want to go ahead and have the both for whatever. We'll have the easy version.
Well, I think right now we only have bytes. I don't think we have something that starts with string.
But we have 2 base 64 string and 2 base 64 chars. It's do we allocate a string for you or do we populate a byte or a char?
Now I'm slightly confused.
I was saying we could get rid of the top one, but the people who are currently using 2 base 64 string that takes a byte array, they may think we missed that one, this spanification. But really what we did is say, well, you should have just done this kind of target approach. So I'm saying we should. So pretend I'm not
I'm still not trying to understand. So basically, like I'm talking the other direction, right? It's talking 2 base 64.
Right.
And for 2 base 64, the only overload that we have today is we only accept bytes.
Right.
So there's no string.
We have 2 overloads because they differ in. We have 2 base 64 string, and I think we also have 2 base 64 chars.
Oh, I see what you're saying. I see. So the question is, do we have one overload that where the destination is span of byte, another one where it's span of char?
Well, it's do we want the top one in
Sure.
Steve's proposal, which is still 2 base 64 string, and I think the answer is yes, because it moves people in the right direction.
Yes.
The 2 base 64 chars, which takes a writable character span of destination, is better, but maybe not what someone wants. So we can add the convenience call for it.
And the question would be,
So we would just write the one that returns a string as go rent a buffer that's big enough for the 3/4 the string length, sorry, the 4/3 the byte length, and then you want it as a string, so we say new string with the span at the end. Whatever we did an allocate for it. Yeah.
yes. Then the only question is, I think this one we should probably do the same thing as the other one.
By the way, the transformation status.
Yeah.
But there's no error in this. The error is you didn't give me enough space to write.
Right, but I still think it's sensible if you have 2 overloads next to each other that they convey the same error the same way. No?
So we still in corefx lab return the same you, but you can only get destination too small items.
Yeah.
So we just ignore the other values.
I guess I don't have.
I think symmetry is more important than is it the absolute minimum you could have done?
The reason ours works that way is because we're trying to go, we're playing around with the whole pipeline strategy. EPA of three pipes.
Right.
Yes, it's very limited.
Right.
Actually, that's the new name. Call it H result. It's good. It's all good.
I call it in result. That's the new result.
The out result. All right. Stephen, do you have preferences for bool versus transformation status?
I don't love the transformation status name, but other than that, not really.
No, I mean like the consistency between from base 64 and to base 64, because this one.
Oh no, I don't have a.
Okay.
I'd rather do whatever the simple thing is for the API than artificially maintain consistency when it's not actually needed. But it's mostly 6 of one, half dozen of another.
I would just not have to try that.
Yeah.
There's consistency with other types, and there's consistency within the type. And
Yeah.
usually from within the type, so that makes it even.
Right. Then let's talk about random.
All right, so this one should hopefully be very straightforward.
Well, we have 45 minutes.
I always say that. So random, there's one complication. Random has a bunch of virtual methods on it. People can derive from random and override stuff. There's already a next bytes method that takes an array. This would just a byte array. This would just take a span byte. The only complication is presumably this guy has to delegate to one of the other methods, and which one. And so I had a little prototype of this, and I chose one that I thought made sense, but implementation-wise, we might want to come back and decide something else.
So what does it even do? It just writes a bunch of numbers to the.
It fills the passed-in data structure, either the array or the span, with random bytes.
And how many? Is that whatever the length of the array is?
Yeah, whatever you give it. So if you gave it an array, it fills the whole thing. If you give it a span, it would fill its count or length.
You want to give it half of that, and slice it.
And that's where the span version is handy. Is if you have some sort of buffer and you only want 5 random bytes. Today you have to allocate an array to do it. Or if you wanted them in on the stack, which is also sometimes helpful. With the span one, you can just stack allocate some memory and pass that in.
Yeah, I think definitely the shape of this one is just it's spot on. There's really anything more complicated than it. And the figuring out what we want to do for overlays and deferences, or for virtuals and deferences.
I went through all the various options, and I think I found the right one, but we can deal with that when we put up a PR.
I would expect that next byte takes a span, just calls the one that takes the array and copies.
Well, the problem with that is how do you pass a span of byte that's, for example, a stack alloc pointer to the overload that takes an array? Because if someone's derived from it, like you could do something internally that just used the same logic, but if someone's derived from random and overridden the bytes one, you'd need to call their derived one, which expects a byte, not a byte array, not a span of byte.
I think this has to be implemented in
Well, but it's if we've added it on an unsealed type as a virtual, it's somebody else's derived type. Is that throw? Is that calling the base class and ignoring the fact that they overrode the next bytes with the index? Or
well, more thinking like if you get an instance of the derived type, and I call this one and pass in span, I think you want the same behavior that you would have gotten if you would have passed an array, no? I think that the default implementation would have to call the one that takes
if we make this have to call the byte one, there's no point in adding this method.
And what we've had to do in some places for compat with when we changed some crypto stuff, mostly we did this after we shipped and found out we broke somebody, is do terrible reflection to find out, are both of these functions derived at the same layer, or do we need to be like, oh crap, I think you came from the old universe and I need to defer backwards. But I don't think that we would want to start adding all of the places we're adding span with, we'll do reflection and figure out, are you a new type or not?
See, I think, so there's basically the base implementation of next bytes. I mean, you can implement next bytes to just basically call sample, which is what, next int calls or whatever. So I think you just implement this as a for loop that loops and gets the individual element and stores it in. And then if the derived Mersenne twister random or crypto secure random or whatever wants to override it, then it can, but at least the base implementation would do something reasonable. And if we wanted to do something like what Jeremy was saying, we could detect whether the other things were overwritten and do something more efficient if it wasn't.
Yeah, I mean, so actually, given this one specifically, that everybody writes it as calling sample. Oh, but the next place calls some magic.
Internal sample also a little bit more efficient. Than internal sample is obviously
because the problem would be if somebody overrode X bytes, didn't override sample, and then now they call the span one on their type, and they're not getting what they expect.
Yeah, but there's so many virtuals on random. If you're not overriding basically them all, your type is largely unusable.
Oh,
unless other than for your own, like you have to know which ones you overrode and then just call those.
Yep.
Well, I guess you could argue that on random, the real primitive is sample, and then the other ones are just, you override them to have a more efficient implementation that doesn't literally like write a for loop over the sample. So in that sense, span would follow that. I mean, like you will get, I mean, if you implement, next that takes next bytes that takes a byte array and sample in inconsistent ways, then yes, the one that takes the span will also be inconsistent as a result. So arguably you could say the implementer of the type fucked it up. If the implementer of the type did something right, meaning that sample and next bytes are in alignment, then us calling sample is still better than us calling the byte one, because at least we don't allocate. I mean, if you really want something more efficient in your next bytes with span, then you have to override that as well and do something smart.
Right. So
I think that's fair. Within
NetFX, there's one type that extends random, which is in service model. They have a synchronized random where they've done every override to do lock call base. So if we added this and they called the span one, not thinking about it, then they would go from doing one lock operation to doing the number of bytes they have monitor enter and monitor exits.
Right.
Which would, well, it wouldn't allocate. That would be a very different point.
Yeah, I mean, is the concern there atomicity, or is the concern there perf? If the concern is perf, they're explicitly changing which overload they're using.
Right.
They should be doing performance analysis. If it's atomicity, then yeah, there's potentially an issue, but I don't know what an implementation would look like where atomicity in that case would matter.
That's fair. So I guess, yeah, because they also overrode sample, they wouldn't, they would still have thread safety. It would just be worse perf because they keep having the monitor be open and closed.
Yeah, except now you have like 6 locks, and so you're no longer atomic for the whole thing, right?
But no one's going to call this new presumably unless they have it out.
Yeah, I mean that's Stephen's point. I think
so, yeah,
change something.
I agree with that.
I would say that generally speaking, whenever you have a type that overrides everything on the base and adds locks to it, like by definition, the type is no longer open to extension, because whatever you do to this type, you're changing atomicity, right?
And their type is internal, so
yeah,
they're not making guarantees that everybody else.
And we don't care about WXF
Well,
anymore, so it's good.
Yeah, there's no answer. See also string.
Yeah.
I think we just implement it directly, just like we wrote the suit and something.
You would write it the way that you wrote next bytes. I guess somebody who overrode sample, it's up to them to figure out what their bytes is now inherited in one day. Yeah.
All right. It only took 5 minutes. It's good. Primitive parse methods. Oh yeah.
So that should say probably parsing format because I subsequently added format, but I forgot to update the title. But basically, every primitive type now, there's what, 10 of them, has parse and toString methods. Parse, try parse, and toString, and these are sort of the span-based equivalents. I took the liberty of, rather than having a bunch of overloads using optional parameters, on the one hand, it makes things a tad bit slower for the common case, because if all you want to do is call parse chars, we need to validate the other arguments, but I don't know that it's sufficient enough to add all the other overloads to compensate for that.
Since we probably would have had them deferring it, it's actually faster because we're not doing it.
So the only thing is, I suppose you want to use read-only span of char rather than read-only span of bytes, because it at least implies that it's UTF-16. Is that fair?
Well, because when you're parsing, you're going from text, so you should go from.
Sure,
char
but
to
if you
char.
go from read-only span of bytes, then you could do any encoding.
Right. So yeah, from bytes to an int is the big convert class. If you think that you have bytes that represent text, then
Well, I guess we couldn't move from any.
you either go through
encoding
something
to
like that
byte.
in system.buffers, or go to the encoded class.
Yeah, if we're going to start treating read-only span char as basically string slices,
Yeah.
then read-only span char is the primitive that we want to operate in terms of for methods like this.
Yeah, I agree.
And the other thing was I needed a verb for the kind of span-based equivalent of toString, so I used the term that the corefx lab has been using and just used format.
Yeah.
Yeah, I think that's, it's not ideal, but I think it's the closest we have, because logically that's what string format does as well, so it's not too bad.
I guess I formatable this is the story.
This will be the first try format. So just board on it, forward it.
Not enough space.
Yeah, because
More than enough.
like toString will throw if you give it a new valid format.
We should-
Since we're not taking an existing format and calling it try format, we decided the common case is you didn't give me enough room, and the format string is invalid. It'll be fairly rare, and then that just kind of starts the validation.
By the way, I formatable data would come back, but it's called I buffer formatable. I think they now buffer writable or something. Means something.
I was just looking to see, like, don't we have an iFormatable? And whether the signatures on those are, that was the other project.
We should probably,
As an FYI, the like int x try parse and whatever. So corefx lab has a project right now that introduces a whole bunch of extension methods to all the base types that are going to, if they ever ship would be very confusing with students.
But if we're adding these here, the corefx lab shouldn't have those.
So it's been, we've spent a decent amount of time doing some optimizations too, so I might want to figure out how to merge them.
Well, this is mostly about APIs, right? So the question is, I mean, I assume implementation-wise we'll do the right thing. But the question is, should we have two different sets of APIs? Like, is this API pattern sufficient for corefx lab? Or are there APIs in a different granularity? They're effectively doing the same thing, no? Except that they have other options, right? This is the whole encoding APIs that we have, right?
Ours are, so we have UTF-8 variants, UTF-16 variants, and then we don't know what the encoding is, so you tell us variants.
Right.
Yeah, even if those are, as long as the method stem is the same, I think that would be fine to have as an extension method.
These are not extension methods, right?
Yes, they are.
So we do an extension
We
method
have
for
extension methods and a primitive static class that you can call.
the extending literally like ins and
Yes, you can call like int, like your int value dot try parse and try format. It literally are these APIs, but we don't do read-only span char and span char. We do byte, and then you tell us what the encoder is that you want to use.
well, I don't think we have extension methods for parts, right? Because they're logically statics, right? So that wouldn't work. So you could only have one for formatting, essentially.
Yes, that's right.
Are you missing static on try parse?
Yeah, they're all static, except for the last one.
Yeah, sorry, that was a mistake.
Is there any reason why you're passing in numeric format info instead of by format provider?
I thought I was passing in what the existing try parse was taking. If that's not the case, then I messed up. It should be whatever the current one takes.
N16 parse, they take iFormat provider. They convert them to numeric format for what they.
It's probably just a copy paste error. Sorry.
But actually, the N16 parse takes iFormat provider, number styles, and number styles in iFormat provider.
Yeah, but
the
I'm
number
talking about the number format.
the number format info is the private info.
Yeah, so the number format
I
info should be changed to iFormat provider.
I see. I see.
I was probably just looking at the internal overload or something. I don't know.
Yeah, it basically immediately calls number format info that get instance from that guy.
Yeah, the private try parse is number format info.
Yeah, consistency is key. Right?
It looks like also minor, but the Boolean ones don't have these same overloads. So
Yeah, that's why next to the Boolean at the bottom, I said no number style, number format args, but that would have been number style provider args.
Fix this then. There should be.
The iFormat provider. Or provides it. As soon as you figure out how to provide things.
And then static. As is this. This should probably be destination. And that should be understanding the other one. Yeah.
For all of the numbering things, it's really special.
Yeah, I'm not going to that test anymore because it's just not useful. So why is bool special?
Just because the existing one doesn't have these, because there's only two values, true and false.
Oh yeah, of course. But I was thinking it's something more.
Does bool not take a culture one at all?
it has iFormat provider.
Because
Oh, it has to, right? Because you can
true
do,
and false are English and invariant, but
yeah. The German versions are obviously much longer.
Actually, I don't see a overload.
Interesting.
We only do the middle.
The two-string makes it better.
Interesting. Nobody cares about true and false.
Yeah.
I think the high level here is we should just match the existing overloads. So,
Yeah.
Yeah.
I think that's fine.
And apparently collapse the overloads and drop the problem. So I assume daytime and daytime offset and time span are the same.
That I should probably check, but and they're logically the same. I mean,
Yeah, logically they're the same, and I may have made some copy paste errors. Basically, whoever's implementing them would just make sure that that these would match the existing ones to the largest extent possible. And I imagine implementation wise, at least for an initial go round, the idea would just be to be, if you look at these things call, they basically either hand down strings or char stars. We would basically go through and replumb everything to work in terms of span or char stars and reuse the existing implementation, and then we can go and optimize that implementation further as possible, either pulling from corefx lab or wherever else. But the initial go around would ideally share as much of the existing implementation as possible.
Certainly, if we already have something doing char stars, it's easy enough to just unsave them first.
right.
Yeah, so modular things like time span, calling the format provider, and everything else calling the provider, but if that matches the existing API, then that's
Yeah, so I think I copied there from what the existing APIs were doing, and so this would just come down to either I made a copy and paste error, in which case we should fix that, or I was right, and then are we mapping as closely as possible to the existing method on the existing type, or are we coming up with something standard or fixing issues in the existing overloads? And I always opted for, unless I made a mistake, opting with what the existing overload was doing or how it was exposing type names or parameter names.
On all of our time things, we have other parsing overloads as well. We have the parse exact.
Oh yeah, so Justin brought that up on the issue, and my initial reaction was, well, maybe we leave that off for now. But if we care about parse exact, we could add those as variants for that as well.
Code I write using datetime.parse, I always use parse exact because the goofy parse is too goofy for my.
Sorry, you trailed out there. Folks that are farther from the microphone, I'm having trouble hearing.
So,
what did you say?
Times I always use parse exact. I have not used parse since parse exact was added.
It's too ambiguous.
So you think everywhere there's a parse exact, we should add parse exact?
Yeah. I mean, I didn't even want to sacrifice parse and just only override parse exact, but
Yeah, the guideline is not to use parsing just because there's too many failure pieces.
So you want to get rid of the parse and replace it with parse exact, or you want to add parse exact?
I go with the latter. I would not remove the parse ones because for whatever they're popular as fuck. Like I think if you depending on what you do, I still think that parse is probably okay. Depending on if you're library writers and if you really need specific behaviors, parse exact is the better one. But I don't see why we would prevent people from calling parse with span. It seems a bit over the top.
So I think that would apply to datetime offset, time span, and if I remember correctly, GUID as well.
Yeah. So anywhere we have parse exact, we should add it.
Yeah.
It's optional parameter collapse overload as well. Yep, go ahead and parse exact.
All right.
So GUID is some of the same, try parse, try format, and then two other methods. a GUID constructor that takes a read-only span byte instead of a byte array, and a try copy to that takes a span byte. GUID already has I forget what it's called. Is it just copy? No, GUID. Oh, it's 2-array. I think it's 2-array or 2-byte array. 2-byte array. That's what it is. So this try copy to would be instead of 2-byte array. But if we want to go with write, so is that what we decided on, like write destination? Try write bytes destination.
Yeah, that's what we had on convert. It seems like that would work here too. So I think the constructor is a no-brainer. And then try copy to right. Bytes, I think is what you said, right?
These do go faster once you get past the initial set of issues.
Does the GUID one also have a copy to from an array?
Say that again, Wes.
Does it have a copy to from array?
It has 2-array.
It has 2-array, 2-bytes array or something like that.
2-byte array, yeah.
Yeah. That's okay.
Yep. Yeah, this looks fine. It looks consistent with what you had.
All right, so for string is interesting. So there's 2 things I've suggested here, and then 1 set of things that I haven't. And let me start with the last one first. There's a whole set of operations I think we need on read-only span char to make read-only span char feel like string-ish. You need things like trim and replace, or well, maybe not replace, but trim at the very least. And some of these methods already exist on the read-only on the span extensions type, but there are some more I think you need. I opened a separate issue for that, and I'm sort of leaving that up to Christoph to drive. So what I've done here are just what I think we need to add to string itself to play nicely with read-only span. I think there's 2 things. One is, we already have a bunch of ways of constructing a string, like from a char array or from a char star and a length. I think we need to be able to support creating a string from a span. You could do that in a variety of ways. Like we could have an extension method on span that created a string, or we could just make it a string constructor, or we could have a static method on string, like create or something that took a span. But to me, constructor seemed the most logical and straightforward approach. The second one is something that lots of people, at least from what I've seen, have bumped up against. I know I have, which is that you often want to create a string and populate it with some data. But to do that today, you have to basically create a char star or a char array, fill that, and then create the string from that, rather than just being able to say, like, I want a string of such and such length. Here is the body, fill it. I know I've seen cases like in ASP.NET, I think I saw a few places where they'll use the string constructor that takes a char and a length. They'll pass in like 0 as the char, and then they'll pin the string, get the char star that backs it, and write, using unsafe code to the string. And I was suggesting we kind of make that a first-class citizen by having a create method where you give it a length and then it calls back to you with a delegate that allows you to populate the body as a span char.
In the ASP.NET case, what are they writing into that string?
An ID or some bytes that they want to convert into a string.
So it's a char array or something is what they have right now.
So they're avoiding the copy cost of string.
And potentially, yeah, and potentially an allocation if you use the char array, although you can use a, you could stack alloc if it was short enough.
Yeah. So it's the double allocation / copy cost.
So logically, what the span is that the string create function gets, it's literally getting the memory that the string allocated, correct?
Right. And it's sort of hiding, you know, the danger of the pin the string and then write to it approach is we've always sort of said that strings are immutable. And this at least kind of gives a head nod to that because you don't actually get the string back until you've already kind of filled the memory. And it's up to the implementation how to do it. If you're actually pinning the string and writing to it, it's obviously breaking immutability.
Yeah, and you can still cheat, but you would really have to go out of your way to cheat here.
Yeah, I guess you could take the span, turn it into a pointer, hold the pointer after you let the span in.
Yeah, but at that point you're just using unsafe code anyway.
Yeah, so
Yeah, at that point you kind of really have to go a little too big of it. Yeah. The only feedback I have is I think it's a good method. I just would avoid the adding another type. I would just make it a fun. No, I guess it's actually.
You're talking about the delegate?
Yeah.
Spans can't be generic type arguments.
What? Say again?
You can't have an action of span. So it has to be pressed delegate. Can we make it a nested delegate type off of string?
Oh,
Just so it doesn't move the namespace.
The other option, this could be some separate API somewhere else. It could be, you know, span extensions or whatever. We don't want to put this on string.
Yeah, because really it's just create a span, fill it with a function, and then call the other constructor.
Yes.
So it seems like it's a reasonable thing, and we probably argue for like 20 minutes over the shape of it, so it's probably a separate request.
I mean, the actual implementation, if you look at all the string functions that create strings today, they all call this like fast string create thing, which actually allocates the memory. And then internally, we do what we tell everyone not to do, which is pin it, get the char start to it, and write to it. That's what this would do.
Yeah,
It just hides it.
I think it's good. I think it's just a separate API request.
Yeah. And you could also imagine doing it as a constructor. The downside to doing it as a constructor is you often want to pass in the state you want to use to initialize the string. And to do it as the constructor, you couldn't make the constructor have generic arguments. So you either need to pass in the state as an object or it needs to be a separate method.
I think it's good to string that create. I just don't know that we have the right thinking caps on right now for new API instead of converted API. I'm happy to let us in this.
I think it needs a little more code.
The other option with the delegate is, I don't know how common it's going to be to pass spans through delegates, but I mean, we could just name this func and, you know, try and come up with one or more delegates that are all in the func family, or action rather, I guess it'd be string create action, that are all in the action family that could be reused for other purposes.
Yep. Or basically like a pre-canned func and pre-canned action types where one of the arguments is spans, you can use them.
Right. So in this case, you know, you could have action that takes a T state and a T, and it would be T state state span of T chars or span of, you know, or something like that. the string create function would specify the generic type that was being used in the span, but it starts to get complicated.
Suppose we need to take every position that exists in, if we wanted to do complete, to take every position that exists in action and make another overload that had spans a fixed type in that position.
Yeah, but the danger there with trying to do it proactively is it's not that every argument might be a span. You could have a span of T or a T, and now you have this huge explosion of possible things. So maybe it would just be as needed. I don't know.
The other thing is unless I'm reading this wrong, this is setting people up, given our current compiler state, for failure, because if you try to use, like most people are going to write that function as a lambda, and as soon as you introduce that, the compiler is actually going to say that's something valid. It'll stop the compiler.
Sorry, say that again. I couldn't hear you.
The fact that you have span anywhere inside of a function, as soon as you create a lambda, it's going to fail to compile.
Why?
That's the way their compiler works right now. They're trying. So Vlad's working on a way to detect whether a span gets created before or after and not used across. But the way that they currently work is because of the way they grab state. As soon as you create a lambda, if there's a span anywhere in that function, it just fails.
I was trying to promote
There's a span anywhere in the function that's calling create?
As of today. So the way that we've worked around it is you would factor out that lambda function into a separate function.
To me, that's just a bug in the compiler they're going to have to fix.
So they are trying to find a way around it right now.
You're saying that happens even if the span doesn't need to get lifted, because obviously it's going to fail if it has to get lifted.
So the last time I looked at his compiler, yes, that was true. I mean, in the last couple of weeks, he might have introduced something where you could detect if it was used ahead of the lambda, but not below, that he would do magic. But prior to that, it was failing for sure.
That seems to be, forget this method at all. Like that in itself seems like a ship stopper to me for spans.
Because it's very limiting. It means that you can't use spans in the context of a lambda at all.
But not even in a lambda. You're saying you can't use spans in the same function that a lambda is also used.
Right.
Yeah, that's bad.
Indeed.
I know it made us go and rewrite a bunch of code in corefx lab. So.
I'd also be fine, that issue aside, I'd also be fine. This is sort of a special function. This is one of the few cases where I veered off of adding overloads and went into Steve on his soapbox about new functionality that we should have. So I'd also be fine if we want to keep this thing separate, as a separate discussion and treat it specially. Oh, sorry. Yeah.
My interpretation of what Robert said is it doesn't allow span and implementation of lambda.
Well, that is always the case because you can't use, because that will require it to capture.
Right.
But he's saying they assume it could be captured, so we block the whole thing.
So I think he said when I was having this discussion that you were in debug builds, it was guaranteed because I think in debug builds it captures no matter what. So debug builds is totally good. And then in release builds, it may compile, but it may end up being incorrect. There's some weirdness there as well.
But doesn't debug build that promote everything as a capture so that debugging is better?
Right.
I see.
Debugging is definitely a problem with that.
So we should just pick the right API and then block it on the compiler.
Well, or just not have that API at all.
I'm just saying that this is going to be an issue regardless of any new APIs we add. People are going to use spans in the same methods that they use lambdas. Totally unrelated, but they're going to use them together, and if that doesn't work, that's a problem for the platform.
I think he knows that. I think that you kind of find ways around it.
No, I remember talking to Jared about it. They're trying to figure out something there. All right.
Okay, so I'm suggesting 4 new overloads on stream, basically one for each of read async, write, and write async. The synchronous methods take a span. The asynchronous ones take a buffer, which I can't remember where we landed, if buffer is still called buffer or if it's now called memory, but whatever that thing is. Sorry, say again?
It is still buffer today.
Okay. And for the read async, one of the historical mistakes I think we made was we should have shipped value task earlier, and we should have made stream read async return a value task instead of a task. We can address that now as well with this new overload. So kind of kill two birds with one stone. These are all pretty simple to implement. Basically, they all get implemented in terms of their existing abstract variant. And if we need to allocate a byte array in order to call that, we get one from array pool or something. The work here is just going to be going and overriding these on all of the stream classes we have where we care to do the more efficient thing.
Sorry, I didn't capture the last part. So basically, you're saying we would override them and call the current one to take byte array.
No, so the basic, we have to, we can't add these as abstract. We have to add them as virtual, which means they have to do something, and they should be equivalent functionally to the existing one. So the base implementation on stream will delegate to the existing overload. So, you know, the read that takes a span will delegate to the read that takes a byte array. But in order to do that, we'll end up having to allocate a byte array. So we'll pull one from an array pool or something to delegate. And then on, you know, deflate stream, network stream, file stream, memory stream, unmanaged memory stream, and so on, we'll override all of these methods to do the more efficient thing. So there will, I think, be sort of three logical pieces of work here. One is to add the base methods, which is easy. Once buffer exists in core CLR, which it doesn't yet. The second is to override it on all of the streams, basically across corefx and core CLR. And then, you know, that'll propagate upstream as well. So ASP.NET will probably end up doing the same thing. And then there are lots of places around corefx where we consume streams, and many of them will want to switch to using some of these new overloads. In particular, places where we're using read async today will want to switch to using the new overload of read async, most likely.
So the default implementation or this implementation will just record area?
So for the synchronous ones, we basically have no choice but to get an array, either allocate one or get one from an array pool, and, you know, either call the existing method and copy, or copy and then call the existing method, depending on whether you're calling read or write. For the ones that take, for the asynchronous ones, we can special case when the buffer or the read-only buffer wraps an array already, and we can just pass the underlying array segment basically to the existing methods. But if it doesn't wrap an array, then we'll do the same thing, get an array, either allocating one or getting one from the array pool and delegating.
Sounds reasonable. It just made me think of the other type we looked at random. If we could do the same thing for this another row there, we could mention a function array and then call the existing overload.
So, sorry, Eric, I'm having trouble. There's something wrong with the microphones in the room. I'm having trouble hearing basically anyone other than Jeremy and Emo.
I think that's because we use the mic from my laptop, I think, and I yell usually a lot, so that probably also helps. I think what Eric was saying is that we set for random that we don't want to override next bytes that takes span as calling the other one that takes byte array for perf. And he was saying that if we're happy to do this here, but just, you know, amortizing the cost by going to the pool, we could do the same on.
Well, the problem is with random, 90% of usage uses the base random class. It's not abstract, whereas stream is abstract. The only people that will use the base implementation on stream are cases where the derived class doesn't override it. But in random, the majority cases, there is no derived class. So there's a logical difference in the types.
I see. You're just saying the impact is much lower there, and so we should just do the right thing rather than.
Yeah, we will override, like 99% of the streams people use are the ones that corefx ships, and will override all these methods there. 99% of the usage of random is the base random type. So we need to make sure the base random type behaves relatively efficiently as well.
Okay, we have 5 minutes. Let's just finish with buffer stream and read-only buffer stream, and then I think we have a logical break for the next time.
Cool. So again, these are a couple of the other cases where I've stepped out of kind of existing overloads and thinking about what we need in sort of the broader ecosystem. Today, we've got memory stream that wraps a byte array. We've got unmanaged memory stream that wraps a pointer, a byte star, basically. We're adding these these buffer and read-only buffer types that logically do the same thing. It's very likely people are going to want to treat them as streams. And so we should consider adding streams that wrap them. Initially, I considered whether we could just have basically, say we're not going to add new stream types. And if you do a check, basically you say, if you can get the buffer from, if you can get the array from the buffer, then you use memory stream. Otherwise, you use unmanaged memory stream. But it turns out buffer doesn't exactly work that way. And there are cases where you can't get the array from the buffer, but that doesn't mean the memory's pinned. And so buffer stream and read-only buffer stream are sort of necessary if you want to treat these things as streams.
Do we need public types here? Can we just not have these internal on this during your stream?
I mean, we can have a factory if that's what you're talking about. Is that what you mean, Wes?
Sorry, what's that?
Did you mean we would expose some sort of factory method instead?
Or just an instance method on buffer? We could use a stream.
Right, yeah, factory, like convert to stream or wrap in stream or something is what you mean.
I'm just not sure we need new types that are just for those things. But when we already have the abstraction, it doesn't look like they're gaining much. Maybe to try to get wrapper was the only thing we gain from the base abstraction.
That's actually a good point. I mean, we did the same thing in WinRT, right? Where we don't give you the actual implementation types. We give you conversion methods and they just return stream.
We could do that.
I mean, the only thing is that
sorry, go ahead.
You would have to have try get buffer and try get read-only buffer, right?
Well, yeah, yes and no. I mean, so what I suggested below was we consider an interface like I_has_buffer and buffer stream and read-only buffer stream with both potentially implemented, as might, for example, memory stream and unmanaged memory stream. If we added this interface, we could say that the intended use case is you just, you do a type check. If stream has buffer, get the buffer basically, and then it wouldn't matter whether these were public or not, they would still implement the interface. If we cared about that scenario.
I see. Actually, that's not a bad idea, actually, because then we can unify it with the existing ones as well, no matter whether they use byte arrays or spans or buffers.
The other thing I want to call out is that I was hoping this issue was going to be more about adding span APIs to the existing APIs as opposed to coming up with new APIs.
Yeah, it mostly is. I veered off a little bit.
Yeah, I don't mind these teams being. I was talking about these, but I was trying to focus this one on. I want to kind of figure out if we can plumb span throughout the VCO.
I think this one is. I mean, as Steven said, right? I mean, like these are still logically overloads. I mean, it's just at the type level, right? I mean, like we have derived types like memory stream. They do it for arrays, and this is basically just the logical equivalent for buffers. So yeah, I mean, like it's multiple options. Right? One option is we just don't have it at all. Then we have it as methods, but we don't give it the type, so we just do it as types. Yeah, there's all pros and cons.
There's another variant, which is we could, at least for buffer stream, we could potentially add a constructor to memory stream. But that wouldn't address read-only buffer stream, and we'd have to look. It could potentially make memory stream more expensive.
You mean more expensive?
Well, it would end up storing a buffer instead of an array, and so all accesses to that underlying array would essentially go through the buffer.
I see.
We also already have a public type called buffered stream, which is
yeah, that was I wasn't sure what to do about that.
Yeah, I mean, this is the only problem that I observed with the pipelines as well, is that one problem that we have to solve, I think, holistically, is that there's too many things called buffer now. That makes it somewhat unpleasant. Like sometimes you like, especially with pipelines, you have this unfortunate call chance where you do buffer.buffer.input.buffer.write, and you're like, what the fuck? I mean, there are too many buffers involved here. That's just another version of that. I think maybe we should have a different name for that. Even renaming buffer to memory wouldn't help, because now we have memory stream and it's not actually taking the memory. But yeah, like there's definitely some work. I should call it RAM.
So as with the string create thing, like we could leave this one off to the side, since it is sort of purely additive and not technically an overload, although I agree with Emo, it sort of logically overloads for existing types we have.
Yeah.
And I'm not against the factory idea either if we want to hide this somewhere. I just, if we wanted to, we do have a type called buffer today, right? Like buffer.block copy and whatever. I mean, you could put a buffer to stream there, or we could put it on buffer of T as well, I guess. Or buffer, we have an extension method on buffer of byte. So we could do that.
I mean, the only downside of the NT ones are they're not very discoverable. That's one problem that we have. Depending on where we put them.
Okay, so since we're end of the meeting, just a meta question. The ones we've already talked about, so bit converter, convert, random, parse format, etc., GUID, and at least the constructor on string, with the exception of the methods that we talked about returning in enum, we consider those all good to go, and we could open separate issues for those and people could start working on them.
Seems like people should be able to start working on the primitive type parts and format.
Yeah, and then we just need to figure out a bunch of them, or at least I guess it was just the convert ones dealt with that enum. So we could leave off convert from that list. But my plan was to go and open individual issues for the approved APIs for people to make forward progress.
It may not be relevant, but the overall timeline for this span stuff, if we start checking it in a master, it kind of implies we're going to put it into 2.1. But I don't know if the rest of the span stuff's going to be ready. It sounds like there's compiler work that still needs to happen. I don't know what the optimization level for span is, in a JIT. Are we ready to start implementing all of it for the next release?
I think the idea was, first of all, it's all 2.1, but 2.1 has now a little bit more time because you push it all a little bit further in the future. But I think the idea of 2.1 as a release is to basically have a public version of span and have it usable across the board. It doesn't mean you have to do all of them. You can still cut pieces out of it that we don't want to do. For example, let's say we could decide not to do the new types, and we could decide not to do the string-based factory with the delegates because of all the complexity we just talked about. But
so I guess the answer is 2.1 is the span.
Yeah, but I think I mean span was basically paved in as a 2.1 release.
Yeah, and to Emo's point, this is all very dialable. I just think we need enough of these APIs that span is usable kind of across the board, and there may be some warts that we need to go fix in 2.2 or whatever comes after 2.1. But as much of this as we can get in, the more useful span will be.
Yeah, and when we say 2.1, we really mean .NET Core 2.1, right? The .NET Standard that is the whole different discussion. Because if let's say we could pull it all off for .NET Core 2.1, and let's say that would ship next week, that wouldn't mean that we could immediately do it for .NET Framework, right? So there's still the question of okay, we can have this version of span that ships for .NET Framework out of band on top of what we already have. But clearly, these are all existing overloads on existing types, which we cannot do out of band. So there may still be the .NET framework like slightly in between where you don't have all the APIs in all the places. Well, we are screwed in the sense that we actually have to ship a release, right? I mean, like that, like we can't do all of them out of band. I mean,
like we'll have to separate the service branches because we can't let it span. Like we have to update the baseline contract so otherwise you can use the span across assembly vendors. Then that'll complicate service.
Yeah, I mean, like, basically what we have to do is, today span is out of band, right? But I mean, for the version we want to actually use it in the platform, it has to go into MS Code, right, in order to really make it useful. Otherwise, you cannot add it to other types.
Then we have to upgrade, but like right now, we're only allowed to call corefx API across assembly vendors.
Right.
So one related thing to that on the corelib subject, Eric, all the vector stuff, I mean, a bunch of the span work, the span extensions and some of the work in corefx lab is taking advantage of vector. As some of that moves into corelib, is that still possible?
It's possible, it's just work that we have to do, and we haven't done it. We've talked about it for a long time, like moving vector T into
Corelib.
On top of that, before we do any of this work, we have to move span down too. Has that work been done now? I don't think it's been done yet.
No, we have,
Span's already in corelib, but
Sure.
buffer is not.
This is runtime as well.
Yeah, well, that'll need to be moved down as to expose the types. We can, a lot of the implementation can be done.
Sure.
And
we have to hard
some
code.
of,
That happens.
and sorry, towards the end of this, like the higher level contracts, they can depend, like we can make forward progress on them as well because they can depend on system.memory.dll or whatever it's called rather than system.runtime. But for some of the core types, yeah, it'll need to be moved to system runtime. I think there's an issue open for that, I think, but hopefully that's coming soon.
Yeah. Another thing we have to be careful with working in NASA right now is that a lot of this is shared with UWP. So, who knows if we're going to fork or put it down, but yeah, we may have to FDEP some of these things with UWP if we don't have the support.
Presumably all this will be under contracted meaning will be that core FP1.
Well, by default, everything in the contract is everything unless you FDEP.
Right.
Whatever configurations are in there, unless they're
That's right. Okay, so we need to be careful until you.
Yeah, so we might break some UWP stuff we start adding.
But that'll be caught by CI, right?
Presumably, assuming CI is working.
Okay.
Testing, so.
Well, CI was never accused to not have enough build breaks, right? So I think that we will definitely see some breaks.
Yeah.
All right, then I think that's it for now. I will upload the notes. I will send the PR out, and then you guys can correct whatever I said there.
All right. Thank you, guys. And
Thank
Emo, plan for the remainder of my long issue.
Yeah, I will do another 2 hour probably for the remaining ones.
Okay.
So I think we probably take another.
Hopefully the rest go much faster. And we need to figure out the transform status thing.
Yeah, let's just go with 2 hours, and in worst case we are done in 1 hour, right? But it's worse than if we have to split it yet another time, I think.
Okay.
Alrighty, thank you.
Thank you.